So let's finish off this part here. For example 11.3.1. Oh, by the way, those of you who have been following this and studying it seriously, I bought a new, well, I ordered, I'll pick it up in a day, I've ordered a new whiteboard. In fact, it's by the same company, so it will still have this silver underlayer. But I reasoned these boards are so cheap. I mean, I got the price of a quality whiteboard, but it was about 10 times more expensive than these things. So I reasoned I'll just go through these, and when they wear out, when they start doing this, I'll just throw it out and buy another one. But I won't rub, and I've learned that when I clean the board, I switch off, I stop filming. And I've learned to use very soapy water and wash rather than rub. And so with less rubbing, I'm less likely to get this kind of phenomenon. So I've learned from my mistakes earlier lectures in this series. And it's a bit bigger. It's about 30 centimeters longer. So 30 centimeters was about that, a third of a meter. So it'll be, yeah, the height's the same, but it'll come out to about here. So I'll be able to have like 1, 2, 3, 4 columns of writing. So that'll give me a lot more scope. Okay. Now remember the proposal for the mapping for the F was of this form. That okay, so we'll use that. Now, this last part, we need to show this. Now, a couple of remarks needed. This is shorthand. This is the multiplicative format for a binary operation on 2 elements. Now, in this context, the binary operator is plus. Okay, so this is just shorthand. There's a binary operator between these 2 elements, and it's plus. Okay. So what we need to show then, and these m's and n's are in fact residue classes. Okay. So what we have to show is that f of here's your plus, here's your binary operation. So now can you see that that's sort of f of mn, which is this, and we have to show that this is equal to fm binary operation fm fn. So f. So this will be I hope you can see this. Okay, so we have to show that this equals this. So we'll work on this left-hand side and eventually derive this. This is what we need to get. And if you look at this, this is of the form f of mn, like this, is equal to fm binary operator fn. Okay, now binary operation in this case is just plus. Okay, so let's now a bit of revision on theory of residue classes. If you, in general, if you have this, something of this form, this is the same as you just add, and the residue classes behave very much like integers. right? So you just add these A and B. So this is the same as this. Okay, that's from theory of residue classes. So if you again, if you're a bit rusty, go back to earlier lectures when we were talking about such stuff. All right, well, now we'll use this formula and this one. So let's work on this now. Now this is just this, okay? Except the n here is now specific. It's now 6. So we just apply this formula to here. So we will get f of a plus b to the 6th, okay? And we can now use this. Now instead of having a here, this was our proposal for the mapping function for f, right? We assumed this. So instead of having a here, we've now got a plus b. So we can write this as this with a plus b here and here. Okay, so let's rewrite that. So that'll become a plus b mod 3, a plus b mod 2. Okay, that's just this. All right, now we can go the other way. Look, this is of this form. Okay, so we can now go from this to this. So we can take these two and split them up like that. This is just from residue class theory. Okay? So we can take this here. In this case, n will be 3. In this case, n will be 2. And we take that and split it up into these two bits, these two. So let's do that. So this then becomes okay, you with me so far? Right, now, next step, is have a look at the form of this, and have a look at this, okay? And the binary operators here are plus. Okay, in both cases. Now this is just the definition of how to use a binary operator on two members of a direct product. Okay. So here this is this is a binary operation. So in a sense you've got like M1 N1, M2, N2, which is of this form, let's say. So we can rewrite that. Here, let me just get this clear. So we can rewrite this because of this direct product. Now we can, so this then becomes A2 A3 Okay, have a think about that. Why is that the case? So this, just taking this from the textbook. This gets to this due to this formula. So why is that true? So you've got binary operator plus here and here. So this is of this form, okay? And this is equal to this, with the binary operator here in the middle, which is what you've got here. So this here is this. And you can take this to this, and this here is this, right? Hope you can follow that. All right. Now have a look at this and have a look at that. Okay. So what is this? Well, it's just that, right? So we can rewrite this then as f of a sixth. Okay. And this will be similarly f